All right, so this video is going through the free response portion of your final review, which is numbers 31 through 40. So numbers 31 and 32 ask us to state the transformations of these two different functions. So when we did this in class, it was in your green packet, Unit 3, and we had a big table that said if you have plus this inside parentheses, it does this, and minus this outside of parentheses, it does that. So if you're looking through this or if you're on your test, I suggest looking in your green packet at that note, those notes to help you with it. But on this one, for example, when I have a plus 1 inside the parentheses, that moves my graph left 1, and then a minus 1 outside parentheses moves it down 1. So if I was adding something outside, it would go up. Subtracting something inside, it would go right. And then this root symbol serves the same function as putting it in parentheses does. So this plus 6 under the root moves it left 6. Number 33 is one of our most recent units. This was all in Unit 7. So we're identifying holes, asymptotes, domain, and range, and sketching our graph. So you're going to need a graphing calculator to do this one. So I start by saying, okay, I want to make sure I know what the horizontal asymptote is, and that's based on the powers, or the exponents. So this has just an x to the first in the top and an x to the first in the bottom. So since they're the same, the horizontal asymptote is a ratio of the numbers in front. So this would have like a 1 in front. So you have a horizontal asymptote at y equals negative 1/2. And then to find your holes in your vertical asymptote, you need everything to be in factored form. So the top is pretty much as factored as it gets, but the bottom, I can factor out a -2, and then I'm left with x plus 1. So in this case, nothing cancels, which means I have no holes. You have a hole from anything that cancels out. And then I have an x plus 1 left in my denominator. So if I set that equals 0, I subtract 1 from each side, then I have x equals -1 is a vertical asymptote. So I can go ahead and graph those. So I have a horizontal asymptote at -1/2 and a vertical asymptote at x equals -1. And then in order to graph it most effectively, you're going to use a graphing calculator, and you'll enter the numerator in first, so you'll push y equals, and then have your x plus 3 in parentheses divided by your -2x minus 2 in parentheses, and then it'll go ahead and graph it right for you on your calculator. So I'll go ahead and show you this graph, and it looks just like this, and I'll kind of go over it in blue so that you can see it a little better. So right here, I have part of my graph right here, and part of my graph right here. And if I had a hole, I would graph the hole as an open circle, but in this case I don't have any holes. So I can go ahead and list my domain and range now that I have my graph done. So your domain is all real numbers, which is this symbol. You could also use -infinity to infinity if you prefer that. Except x can't equal anywhere there's an asymptote or a hole. So in this case, there's an asymptote right here at -1. So x can equal all these things, but it can't equal -1. And then the range is the same idea, except we're dealing with y values. So if I look at my y values, they equal everything from clear down here to clear up to the top, except where this asymptote is, which is at -1/2. And if there was a hole, that would also be not included in my domain and range. But in this case, there's no hole, so I don't have to worry about that. And then we move on to graphing polynomials. So I'm going to go ahead and just have the graphs up and show them to you. So the biggest thing, you kind of have two options when you're graphing a polynomial. One is to just plug it in your graphing calculator, similar to how I just showed you on the previous problem. Another way that you can do it is based on the parent graph. So if I look at this right here, this is a squared function. So its parent graph is y equals x squared, which is a quadratic. And the graph for that, before any of these transformations happen, looks like this. It's just right at the origin, a nice upwards facing parabola. But then I know from this -4 in parentheses that it's going to move right 4. And then from this +2 that it's going to move up 2. And then this negative out front flips it over the x-axis, so that's why it's upside down. And then the 1/2 makes it less steep, so that's why it's a little wider or less steep than the others. So you can graph the parent graph and then make these transformations to it, or you can just plug it into a calculator. So that's the same idea on this one. This one, the parent graph is y equals the square root of x, which looks like this. And all that happened to this one is it moved up 3. So we just take that graph, move it right up 3. Then number 36, we're stating the key features of a graph. So there's a lot of key features, so this may take us a second. Some of them I think you have done for a while and should hopefully catch on faster than others. So we'll start with x-intercepts and y-intercepts. So that's just where does it cross the x-axis and where does it cross the y-axis. So x-intercepts is where it crosses this axis, which is right here, and I'm going to go ahead and round, which I'm fine with you doing too. It's about at 0 or at 3, 0. There's an x-intercept. And then there's a y-intercept right here, which is at 0, 2. And then another thing that it will have you find is the relative minimums and the relative maximums. So relative minimum is wherever there's like a valley. So right here, where it valleys, there's a minimum. So there's a minimum at 0, 2. And then a maximum is where there's a peak. So there's a peak at 2, 6. And then we do what's called end behavior. So end behavior is what happens as x goes to infinity, where does y go? And as x goes to negative infinity, where does y go? So as x goes to infinity, which is further and further this way, y, we notice, is going further and further down, which is negative infinity. So as x goes to a positive infinity, y goes to a negative infinity. Whereas x goes to negative infinity, which is further and further this way, y is going up and up and up and up to a positive infinity. Then our next part, we've got to find our increasing intervals, decreasing intervals, positive intervals, negative intervals, and then we've got to decide if it's even, odd, or neither. So we'll start with increasing. So these intervals, we always go from left to right and use the x values of our points. So clear over here is a negative infinity, clear over here is a positive infinity. If I start on the furthest left of my graph, which is here, and it keeps going and going and going, so it starts at negative infinity, it is decreasing till I hit this point. And it's very tempting for people to say, okay, it's decreasing from negative infinity to 2, but we're using the x value of this point, and this point is 0, 2. The x value is 0, so it's decreasing from negative infinity to 0. And then from 0, it increases till the x value of this point is 2, so it's increasing from 0 to 2. And then it goes back to decreasing from 2 on and on and on and on and on to infinity. So it decreases from 2 to infinity. Positive and negative we list the same way, but positive is just where it's above the x-axis and negative is where it's below the x-axis. So this is all above, 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 till here. So from negative infinity till about 3, the graph is positive, and then starting at 3, going on forever to infinity, it's negative. Then we have to decide if it's even, odd, or neither. So a graph is even if it's symmetric on this axis. So if you could take this side of the graph and flip it over the axis and they are the same, which in this case that's definitely not true, so it's not even. An example of an even graph would be one that maybe looked something like this. I take this half, flip it over, and it's the same on both sides. An odd graph is a graph that we could take and rotate it around this axis, and then it would be rotated 180 degrees and have it be the same. So for example, if we had a graph that looked like this is the graph of x cubed. If I take this part and flip it 180 degrees, it would land right on this part. So that would make it odd. But that's not true in this case either. So if it's not even and it's not odd, then it has to be neither. So we would say this is neither. 37 and 38, from my experience, are two that people actually generally are pretty confident in doing. So we're stating the total, real, and imaginary solutions. So total, real, and imaginary. Total comes from whatever our highest exponent is. So in this case, the highest exponent is a 4. So there's a total of 4 solutions. And then real comes from however many times it crosses the x-axis. So in this case, we have 1, 2 that are real. So if I have 4 total, and 2 of them are real, then the other 2 have to be imaginary. On 38, again, the highest exponent's a 4, so I have a total of 4. But this time, there's not any that cross the x-axis, so 0 are real. And if there has to be 4 total and none of them are real, then all 4 of them have to be imaginary. 39 was from our Unit 6, where it was actually the yellow homework assignment, where we're solving inequalities. So if I look at this right here, the first thing I have to do is find critical values, which I find by setting the top equal to 0 and setting the bottom equal to 0 and solving. So the critical values for this one are -3 and 4. And I then need to graph that on a number line. So any critical value that comes from the denominator will always be graphed with an open circle, because I can't divide by 0, so I can't have it be included. And then whichever critical value comes from the top depends on this sign. If it's just less than or greater than, like this one is, that's a not included sign, so it would be an open circle. But if this had like an equal to with it, then this would be a closed circle. So I'm going to go ahead and graph those on my number line. So I have an open circle at -3 and an open circle at 4. I then, in order to figure out which way my arrows go, I've got to plug in a number from each of these intervals. So if I plug in a number less than -3, I'll try -4. -4 plus 3 is a -1. -4 minus 4 is a -8. And that's a negative over a negative, which is positive. So the numbers in this interval are positive. Then I do the same thing. I pick a number in here, and I'll pick 0, because that's an easy number to do. So 0 plus 3 is 3. 0 minus 4 is a -4. 3 over a -4 is a negative number. And then one more time with a number from over here. So 5 plus 3 is 8, and 5 minus 4 is 1, and that's a positive number. So if I look right here, this is looking for numbers that are less than 0. So numbers less than 0 would be a negative number. So wherever my graph is negative, which is right here, that's where I'm going to draw my graph, because I'm looking for numbers less than 0. And then I can just list this as an interval. So since these are open circles, I use parentheses, -3 to 4 parentheses. And all of this is expected for this problem, to find the critical values, graph it, and list the interval. Last one on your review has to do with this very last unit we've just done, Unit 8, where we're creating equations and rearranging formulas. So Bob wants a square garden, so I'm going to go ahead and draw a square garden. That's 196 square feet, so it has an area of 196. How long should he make each side? So these are the length, and we don't know how long it should be. That's what we're trying to find. So write an equation and solve it to answer this question. So fortunately, it gives me the formula for area right here. So area equals length squared. And I already know the area is 196, but I don't know the length. So I want to solve this for length. So to get L by itself, I take the square root of both sides. So then the square roots cancel, and L is equal to the square root of A. And I know what A is, it's 196. So L is equal to the square root of 196. So if we plug the square root of 196 into a calculator, so the square root of 196 is 14. So the length equals 14, and this is in terms of feet. So 14 feet. And that is it for your review. And your final looks exactly like your review, it just has different numbers. So if you go through your review and you make sure you understand and know how to do every single problem, then you'll be in really good shape for your final. Your last bonus point you can earn is if you draw a heart around number 3 on your test, then I will give you 1 extra bonus point. So there's 3 bonus points available, so hopefully you can find all 3.